Hello everyone, welcome to today's program. With the global energy structure accelerating its transition toward renewable energy, the importance of energy storage technology is becoming increasingly prominent. This episode is our sixth technical interview. Today, we've specially invited an expert in the energy storage field, Engineer Xia, to talk with us in depth about environmental testing for energy storage systems. Hello, Engineer Xia.
Hello, host. Hello to all our viewers. I'm very glad to be here and have this opportunity to share with you.
To begin with, could you give us an introduction to the energy storage industry and explain why we decided to produce this video on energy storage environmental testing?
Sure. Under the global trend of energy transformation, energy storage technology has become the anchor that balances power supply and demand and enhances grid stability. Its safety and reliability directly determine whether the entire energy system can operate stably. However, energy storage equipment can experience performance degradation, safety risks, and technical bottlenecks when operating under extreme environmental conditions. These issues have become major obstacles to the industry's high-quality development. So in this episode, we want to give you a brief overview of energy storage environmental testing, its definition, industry pain points, test subjects, test scenarios, solutions, and more.
I see. So why do we need to conduct these extreme environmental tests? What problems do they help solve?
There are mainly 6 reasons. First, early verification to ensure performance stability in extreme environments. Through extreme environmental tests, we can evaluate performance degradation levels and ensure the product meets design requirements, such as capacity, efficiency, and cycle life. Energy storage products may be deployed in harsh environments, extremely high temperatures like deserts, extremely low temperatures polar regions, high humidity, high altitude, heavy dust exposure, and more. These extreme environments directly affect the physical and chemical properties of the equipment. For example, high temperatures accelerate battery aging and may cause thermal runaway. Low temperatures reduce battery activity and charging or discharging efficiency. High temperature and high humidity environments can lead to internal short circuits or corrosion of metal components, which may shorten the lifespan of our equipment. Low air pressure at high altitude affects cooling and insulation performance. Dust may clog our cooling channels, while vibrations can loosen our connecting components, leading to poor contact or malfunction. Second, optimizing design to enhance safety and reliability. Energy storage systems have high energy density and complex electrical structures, which inherently carry certain safety risks. Extreme conditions may amplify hidden problems. By simulating high-temperature cycling, low-temperature startup, salt spray corrosion, vibration, shock, and more, we can identify design flaws or material weaknesses in advance and optimize thermal management structures, sealing designs, and anti-vibration components to reduce safety risks. Third, meeting industry standards and regulatory requirements. Different regions around the world have strict requirements on environmental adaptability, like IEC, UL, GB, etc. Passing extreme environment tests allows products to obtain certifications needed for market entry. We can avoid legal risks or market entry barriers caused by non-compliance with standards. Fourth, extending product lifespan and reducing maintenance cost. Extreme conditions accelerate aging and shorten the lifespan. For example, batteries may age 2 to 3 times faster in high-temperature environments. Frequent temperature cycling may also cause material fatigue, leading to structural deformation or seal failure. Through testing and subsequent design optimization, such as using high-temperature resistant materials or improved cooling designs, we can significantly extend product life and reduce maintenance cost. Fifth, adapting to diverse application scenarios. The application scenarios for energy storage products are very diverse. For example, grid integration of renewable energy requires adaptation to extreme natural environments, such as high temperatures in deserts, and power supplies may be deployed in high corrosion or high temperature workshops in industries like chemicals and metallurgy, as well as in extreme climate regions, such as Arctic research stations or photovoltaic power plants in Africa. Through extreme environment testing, we can ensure that our products operate reliably in various scenarios, thus expanding our market coverage. Sixth, enhancing brand competitiveness and user trust. Products that pass extreme environment tests send a clear message of reliability, safety, and durability. strengthening brand reputation and market competitiveness. In short, extreme environmental testing is a key step for energy storage products transitioning from lab development to real-world deployment. It not only concerns product performance and safety, but also directly impacts our market competitiveness, user trust, and long-term economic benefits. By simulating real-world extreme environments, companies can identify and address issues in advance, ultimately delivering more reliable and durable energy storage solutions.
Listening to your explanation, it's clear how crucial extreme environmental testing is. So, what exactly are the test subjects in energy storage environmental testing?
They can be said to be the entire industry chain from battery cells to complete systems. Specifically, battery, cells, modules, packs, electrical systems, BMS, PCS, transformers, breakers, structural and protection components, container housings, insulation, fire protection systems, auxiliary equipment, thermal management systems, ventilation systems. Overall, common test objects include battery clusters, string-type or centralized PCS units, small commercial or industrial energy storage systems, and large containerized systems, 20FT, 40FT containers.
That's quite a range of test objects. So what are the common test conditions?
Common environmental test conditions revolve around temperature, humidity, air pressure, vibration, corrosion, sand or dust, and smoke, aiming to simulate harsh real-world scenarios to verify the product's adaptability and reliability. For example, high-temperature testing involves sustained high temperatures ranging from 60 degrees Celsius to 85 degrees Celsius for several hours or even days. This evaluates the performance of energy storage products in high-temperature environments, assessing degradation, thermal runaway risks, heat dissipation capabilities, and temperature cycling with rapid switching between high and normal temperatures. For example, a temperature range of -40 degrees Celsius to 85 degrees Celsius simulates the day-night temperature differences or extreme weather conditions, which accelerates battery aging, electrolyte decomposition, and deformation of sealing materials. Low-temperature testing will maintain temperatures between -40 degrees Celsius and -20 degrees Celsius for several hours or even days. To verify low-temperature startup capabilities, charge or discharge efficiency, and material catalytic risks, low-temperature charge or discharge tests involve performing full charge and discharge cycles at low temperatures to assess battery activity. During this process, the internal resistance of the battery increases, the capacity decreases, and electrolyte freezing may occur. Constant humidity and heat testing is conducted at a temperature of 40 degrees Celsius with a ±2 degrees Celsius tolerance and humidity levels ranging from 90% to 95%. Lasting from 96 hours to 168 hours. This evaluates the impact of high humidity on battery insulation, metal component corrosion, and material heat absorption properties. Alternating humidity and heat testing, cycling between high temperature and high humidity, and low temperature and low humidity. For instance, at 60 degrees Celsius with 90% humidity, transitioning to 25 degrees Celsius with 50% humidity, and then to -10 degrees Celsius with 30% humidity, simulating the alternating temperature and humidity fluctuations similar to day-night temperature shifts and humidity variations. Salt spray testing uses a 5% sodium chloride solution sprayed in an environment with temperatures of 35 degrees Celsius, ±2 degrees Celsius, sustained for 48 to 500 hours to verify the product's corrosion resistance in marine or salt spray environments. Low-pressure testing reduces the air pressure to 50 kilopascals to 70 kilopascals, equivalent to altitudes of 3,000 to 5,000 meters with a temperature of 40 degrees Celsius. This simulates low-pressure conditions in high-altitude regions like the Tibetan Plateau, assessing our cooling and electrical insulation performance. Sand and dust testing uses talcum powder or silicas and suspended in particles at a concentration of 2 kilograms per cubic meter, with a wind speed of 8 meters per second, lasting for 8 hours. This evaluates the product's dust-proof capabilities in desert or sandstorm environments. Through these tests, energy storage products can be thoroughly validated for their performance, safety, and reliability under extreme environmental conditions, ensuring they meet the needs of various application scenarios.
These conditions sound quite strict. So what are the solutions our company offers for these tests?
We provide targeted solutions based on different test objects. For 20-foot and 40-foot containerized systems, we offer over 300 cubic meters walk-in temperature or humidity chambers. It includes the temperature chamber body, electric sliding door, refrigeration unit, electrical control system, fire protection system, monitoring system, steel platform, flatbed truck, and electric drive system. These are mainly used for environmental testing of energy storage containers. For these types of test samples, the key focus areas include sample information such as load, heat generation, air inlet and outlet positions, air volume, layout dimensions, test conditions, sample introduction plan, fire protection design, and external supporting resources. For smaller test objects such as small energy storage systems, commercial or household storage, or centralized PCS, we have a mature walk-in solution ranging from 45 to 200 cubic meters. In these test sample solutions, the main focus remains on sample information such as load, heat generation, air inlet and outlet positions, air volume, layout dimensions, test conditions, sample introduction plan, and external supporting resources. For test objects like battery clusters or string-based PCS, we offer walk-in solutions of 15 cubic meters, 18 cubic meters, 36 cubic meters, and 45 cubic meters. In these solutions, the key focus areas are sample information, layout dimensions, and test conditions.
Seems like our solutions are very comprehensive. So what customer concerns can we address?
We provide several value-added services. First, we provide comprehensive, customized services to assist customers with site planning. Second, we offer a variety of sample introduction and extraction solutions to meet different site requirements. Third, we precisely design heat generation to ensure proper configuration. Fourth, we provide airflow simulation reports to ensure the simulated conditions closely match real-world usage environments. Fifth, we set the environmental chamber temperature and control the temperature deviation between the test object and the air inlet to within 2 degrees, ensuring more realistic temperature simulation. Sixth, we support diverse testing scenarios including constant temperature and humidity as well as high heat load testing. Seventh, we integrate special functions such as icing, rain, snow, and sunlight simulation.
Very professional. I'm sure our viewers now have a much deeper understanding of energy storage environmental testing. Before we wrap up, is there anything you'd like to say to those who follow the energy storage industry and the topic of environmental testing?
The energy storage industry is developing rapidly. Environmental testing is essential for ensuring high-quality products. I hope more companies and professionals will attach importance to this area, continuously improve product performance and safety, and work with us to promote the industry toward greater reliability and efficiency, contributing to the global energy transition.
Thank you for your wonderful insights, and thank you to all our viewers for watching. If you have any questions about today's program, feel free to leave a comment under our video. We'll arrange for someone to reply as soon as possible. That's all for today. See you in the next episode.
Goodbye.